Hello and welcome to the fifth video on our series on the effect of demand shocks on employment. In this video, we're going to be solving for the equilibrium of the model in normal times. And I'm going to be clear about what normal time means in just a second. So we're going to assume that in normal times, all counties work beautifully. They are all the same. And so because all the counties are going to do the same thing, we're going to be looking for a symmetric equilibrium, where the value of the variables in all the counties is equal. In this symmetric equilibrium, we can start to use the first order conditions and the equilibrium conditions that we discussed last time. So for example, we had a non-arbitrage condition and labor demand that told us that the ratio of wages better be 1, because we said that wages had to be equal to one another. And then we also had a result from our labor demand saying that the wage in non-tradables better be equal to the productivity, the revenue productivity, and that the wage in tradables better be equal to the revenue productivity. So this means that this ratio of productivities here and prices has to be equal to 1, from where we can also get the ratio, the relative price of tradables to non-tradables pinned down in the model with the ratio of productivities A over B. This is going to be important later. Now from market clearing and consumption demand, we can further solve for some other of the variables. So let's look at what's happening. This is the market clearing condition for tradable goods. But remember, we're looking at a symmetric equilibrium, so all the C's look the same. So we know that YT in every county has to be equal to B times ET. That's because we have the total output here of each county for tradable goods. And then on the other side, we're going to have total demand for tradable goods in each county. Remember from before that what we wanted in the optimal allocation of the consumer is that the consumer wants to spend a fraction 1 minus alpha of its demand on tradables. So if the demand is 1 and I want to consume a fraction 1 minus alpha of that in tradables, I need to divide by PT to get the real demand for tradables. So that's where this variable is coming. And I'm going to be going back and forth a little bit in these slides, but I just wanted to be clear how we're solving for the equilibrium. This other condition is the same. We have here the total output of non-tradable in each county has to be equal to the total demand for non-tradables in each county, which has to be equal to alpha over P and T. So let me just quickly go back to make sure we understand what we're doing. So out of the consumer's problem, we knew that the expenditure in non-tradables and the expenditure in tradables were both fractions of total demand. Now, we're assuming that total demand is equal to 1. So that's what the 1 is doing there. It's instead of this D, we're replacing for a 1. And then we're dividing by the price, both sides, so that we get that the total demand for non-tradables is alpha over P and T, and the total demand for tradables is 1 minus alpha over PT. Let's go back to where we were. These are these two equations, 1 minus alpha over PT, alpha over P and T. That's where they're coming from. Okay, next step. We can also use the first order condition, that's going to be the line just before the line I was mentioning, to get an expression for the ratio of CNT to CT. Now we know that in equilibrium, this ratio has to be equal to the ratio of outputs. So we know that CNT over CT in the optimal allocation of the consumer has to be equal to alpha over 1 minus alpha times PT over P and T. But we also know from the result we just derived what PT over P and T has to be. It has to be A over B. So that's what we're doing here. We are replacing PT over P and T as A over B, canceling it with the A over B on the other side, which leaves us with E and T is equal to alpha over 1 minus alpha ET. We're going to go back to that in a moment. Because we know that the labor market has to clear as well. So ENT plus ET has to be equal to 1. Now, if you replace this relationship here in this equation, you can solve directly for ENT being equal to alpha and ET being equal to 1 minus alpha, which in turn, it's going to give you the level of CNT and CT, because you know CNT is going to be A alpha and CT is going to be B 1 minus alpha. And that's exactly what we're doing here. And with that, we have all the real variables of the model. So we have the exact value of employment and the exact value of consumption. What's left for us to find is the level of the nominal variables like wages and prices. So that's what we're going to do here. The first thing is to know that the budget constraint needs to hold. Remember, demand is equal to 1. So we have here all the budget constraint. We just found out what CNT and CT have to be in equilibrium, A alpha, B 1 minus alpha. And we also know what PT and PNT are relative to one another. So we know that we can replace PT as A over B times PNT. Why do we know that? From here, sorry, one more. Here, PT is A over B times PNT. So if you replace that in this equation in the budget constraint, it's going to be an equation only in terms of PNT. You're going to find that PNT is equal to 1 over A. And hence, from that same equation, PT is 1 over B. And then finally, from equilibrium in the labor market, you can find the wages have to be equal to 1. We knew they had to be equal to one another. And we also knew that they had to be equal to the marginal revenue productivity. And so we knew that this one was A times PNT, and so PNT is 1 over A. That's what gives us the 1. And with that, we have all the variables of the model, and we know how to find each and every one of them using the different equations, both market clearing conditions and optimality conditions of our agents.